Hey there and welcome back to the C# for Total Noobs training course. During the last few parts we've discovered some very exciting things about classes, inheritance, methods and things like that, which is all okay, but now it's actually time to move on a little bit towards a deeper discussion or a deeper look into some data types that are very important in C# and with which we will work a lot during our career. So today we will start to look into these data types by talking about arrays. So the first thing that we would have to know about the arrays is that this is actually a very important part. And as we will see later in another video, they are fundamentally different, or there is a fundamental difference between an array and, for instance, a list. And if you are familiar with other programming languages, this concept might be a little bit vague for you. But for C#, there is clear distinction between an array and a list, and that's why we look right now in this concept of arrays, and we will start with one-dimensional arrays. But then at a later point, we will talk also, or we will discuss also other collection types like lists or dictionaries or stacks and queues and things like that. But let's start with arrays for now. So the first thing that we would have to know about arrays is that, well, they are a sequence of elements, so nothing more than that. And these elements, which is very important for C# and for any strongly typed language, is that all elements of an array are of the exact same type. So this means that we have a predictable collection of elements, and we know that each element of the collection will be exactly in the same format, in the same data structure as the other elements of this array. And this is very important because in other languages like JavaScript or languages generally that are not strongly typed, well, things might differ a little bit. We might at a certain point get a number, then a string, then an object, and things like that. But in C#, this is not the case. So in a C# array, all the elements will always have the exact same type, which is very important. And this is a question that you will receive a lot of times during an interview, for instance. Then one other very important aspect of an array in C# is that the order of the elements is fixed. So we have all the elements in a certain order, which means that we can actually access them by their index. And then another third very fundamental part about an array in C# is that it has a fixed size. So when we declare an array, we always have one way or the other, as we will see right when we jump into coding in a few minutes, that it is important to specify the size of the array. And this is really important because you cannot add elements to an array, and you cannot remove elements from an array. If you want to do that, what you would have to do is actually create a new array that consists of the elements that you want. But you cannot simply add an element to an array. And this is really a fundamental part, that it is fixed sized and that you cannot simply add elements to it once you have declared the exact size of it. So this is a really important part. And as you can see here in this very small drawing, we have, I would say, 3 different components of what an array is. So we have first the entire array itself, which is usually an array of elements. Could be any type of element, could be an array of our custom types, for instance. But I guess for now we'll mostly talk about arrays of integers, because it also allows us to go through some exercises that you might get as interview questions later when you want to apply for a job. So then each element in the array has a certain index. The index actually represents the position in this array where that element resides. And indexes always start to be counted with 0. So this means that the first element will be always on the index 0. The second element will be always on the index 1, the third element on the index 2, and so on, which is very important. And that's actually everything about arrays. Now, of course, there are a few other things here about arrays that, well, you can look through them, like how you can access elements of an array, how you can set an element of that specific an array using that specific operator, which is the indexer. And then, of course, just as said, that an array index starts always with 0, so the first element will be always on index 0. And this means that, well, we have a property of array.length, which tells us how many elements do we have in an array, which means that, let's say, that the last element of the array has the index length -1. We will see this once we get to practice this. Then, of course, array elements, as said, can be retrieved and changed by the indexer operator that we have here. And that's pretty much everything that I wanted to show you from the theory perspective. So I would then say, let's go over and start to look a little bit into how we can actually play with arrays in C#. So let's just remove this, or maybe just add here a console a read line or read at the end, so that we keep our console open. Now, the first thing that we want to do, as said, we want to see how we can declare an array. And we have actually two ways to start working with arrays. So first of all, we can do it like this. We can simply say that, hey, we want a data type, an integer array. Let's call it my first array. And this should be equal to new int array. But the interesting stuff here is I said to you that when you create an array, you have one way or the other to specify exactly how many elements do you intend actually to put in this certain array. It's not important from the beginning that you also assign the elements to their places, but you have to specify exactly how long the array would be. So this is actually used because then C# can, or .NET can then actually infer how much memory it's needed actually to accommodate the size of the array that you try to build. So let's say here that we want to have an array of integers that has 3 elements. So this is what we have done here. Then, as said, we can set the elements also using that indexer. So we could simply say here my first array, and we say that at the position 0, so which is the first position in the array, we want to have the number 10, for instance. Then we can say my first array, and here we can say that at the index 1, so the second position, then what we have here is, let's say number, let's say 7, for instance. And then let's add the third element in the array, which will be on index 2, and this would be the number 5, let's assume. Now, the interesting part here is, for instance, that if you want to say here, for instance, my first array, and let's say 3, which would be the fourth element, and if we try to assign once again the same number here, then the problem is here we would get an exception. Because what we try to do here is to assign a number on the fourth position, so the index 3, but the array has only a length of 3. So this means that we try to assign a value that is out of the bounds of this array that we have specified. And that's one very popular exceptions that you might get when you're working with arrays, like array out of bounds exception. It always happens if you try to add new elements to an array, and you try to do this for an index that is out of the bound, so that is bigger than the length declared for the array. So let's just then remove this line here. Now, what we can do further is we can actually look into how we can get started with an array in a different way. So let's say here that we want once again to have an int array, and let's call it my second array. And in this case, what we will say here is simply we will have numbers 1, 2, 3, and 4. So what happened in this case is that, well, we know we already assigned numbers for this array. So this means that as we assigned here 4 numbers, this means that the array will of course have a length of 4. Which will be would be the index 0, this would be the index 1, this would be the index 3, 0, 1, 2, and this would be the index 3. So in this case, we don't have to specify explicitly the length, because the length can be inferred from the fact that we have already added here 4 elements to this array. And then if we would try, for instance, to do the same thing that I wanted to do previously, like my second array, and I would like to assign something on the index 4, which should be out of bounds, because once again, this is index 0, this is index 1, this is index 2, this is index 3. So if we want to assign here another number, like for instance 7, whatever, it would happen exactly the same thing. So we would have an exception because we tried to add an element to an array, but the array is already full, so we cannot simply append to it. If we want to also add 7, we would have to declare a new array and also add the 7 to it, which is very, very important. So that's basically, and this is called, by the way, a collection initializer. And we'll work with collection initializers a lot also when we will talk about other collection types that are different, you're fundamentally different from what we see here for the array. Now, if I want to, well, write or print all the elements in an array, I can simply use a for. So I can do that with this for loop, and I would write it manually here. So then, of course, in a for loop, as we said, we need to specify an I, which would be 0. So this would be the starting index. We want to go and loop as long as I is my first array dot length. So this specifies the length of the array, and the interesting part here is, and let's also add I++ here. So the interesting part is here, and here you have to be careful, especially if you are at the beginning stages or you're actually just starting to learn coding, is that this operator is very, very important, because as long as we have here the condition that I should be less than the length of the first array, remember, the last index is always length -1. But if we have here is less than, then this would work. But if we would have here less than or equal to, then it would also try actually also the number of the last element, and that would be outside of the bounds of the array, because as said, the array and all collections actually in C# are 0 based, so they start at 0. So here we have to be careful with that. So we will let here only this operator, which is less than, and that should actually work fine. So then in this case, we can simply do here a console write line, and we can just print the number of the array, and that could be very easy to do, because it would be my first array, and we can use once again the indexer, and the indexer in our case is I, because I will be actually increased after each iteration. So we can simply use this as a dynamic indexer. So in this case, if we run this application, let's run it. And I would expect then to see all the numbers that we have here on a different line. So we have 10, 7, and 5, which is correct. This is actually what we have expected. Now, of course, as you can work with arrays, if you want to iterate through them, you can of course go through all or you can go through all the elements using a for loop, but you can of course use also a for each. And here I would say that for each int, sorry, that jumped away. So for each int element in my second array, we will just want to print console.writeLine, and we will write or print on the screen the current element. So let's run this application again, and the result should be that we also have the second array printed here, which is actually exactly what we wanted. Now, once again, if you use the for loop, then you have to use I as the indexer to access the element of this array. But if you use a for each loop, then you can simply just access the current element. And in our case, you can just simply print it, because it's an integer, and this could be printed to the console. Now, one important thing here is to note that we cannot simply console writeline directly the array. Let's see what happens in this case. For instance, if we do here something like console.writeline, and here in this console.writeline, let's try to print the my first array. Now, the problem here is that, of course, this array has a toString method attached to it, like actually all the objects, but it's actually the method that gets called when .NET tries to print this to the console. So no matter if you use the toString or if you don't use the toString, it is actually used anyway. So if you run the application right now, you see that you just get here that it is an array of system int32, which is an integer. So if you just try to print out the array, it always will actually print you the type of the array, not the elements themselves. So if you want to have a toString method that would, of course, print all the elements in the array instead of printing the system.object, you can just simply override the toString method, and then everything should be fine. But that's not something that we would like to do right now. Okay, then let's go a little bit further and let me maybe comment out the code that we have written so far, because I don't want it to be displayed every time that we run the application, as we want to do other stuff here. So as a next step, one of the common exercises that you will get on different interviews and things like that is, okay, write a very, very small application in which you can, or in which a user can input some numbers, for instance, in the console. Then you should place them in an array and then actually do different type of operations with that array. And that's exactly what we will try to do. But first, of course, we will need to get this idea on how we can get the elements from the console and then add them to an array. So then let's see. The first thing that we would have to do, as the array once again is fixed size, we have to also first instruct user to specify the length of the array. So then the first thing would be to get the array length. And in this case, of course, we can simply use, and I guess I will just in this case place a code here. Sorry. That was actually linked to a YouTube video. So we would have this int length and then int parse console readline. So that would actually take us the length of the array. And then what we can do is, of course, we can declare a new array that would be of the length that was specified by the user. Now, the idea here is that how can we actually get the user to provide a number and then another number and then one more number? Well, it is actually very easy, because we can use for that a for loop as well, because we know how much or how often should we actually go through the array, or how many times do we need to ask the user to provide us a number for the array, because the user already has specified that number. So in this case, we would have int I equals 0, I is less than length, and then we would then increase I, of course. And each time we go to that, we'll say here console.writeline. And here in this console.writeline, we can use string interpolation. And we will talk a lot about strings just in a few parts from now, because strings are also very, very important in C#, and they are very, very specific and particular. They have some very interesting characteristics. Now, of course, here we can say add element, and then user should will specify also on which position. So we specify the index, and then the user can actually specify. And then what we can do is simply we can say that my third array of I, and we just int.parse the console read line. Now, of course, in a more realistic application, what we would also have to do is we'll have to check that what was provided by the user is really an integer and not a string or something else. We could use int try-parse for that, but for now, that's not actually in the scope for this specific part right now, where we want to talk about the arrays. And actually, then that's it. After we have done this, we have a fully functional array. So if we have a fully functional array, we can then simply go with a for each var number in my third array, and we can then just simply console write line the element. Okay, and it's number. Good. So if we run this application, I guess that we would be good to go. Now, of course, we would have to be asked to provide a number, but something actually happened here. Of course, it happened here because we would have to. We haven't added any instruction on what actually should be done. So I say I have 3. And then element at position 0, I would like to be 1. Element at position 1, I would like to be 2. And element at position 3, I would like to be 10. And then we print the array, which is 1, 2, and 10, which is exactly what we wanted. Now, let's go one step further and also actually wire it up to what we have done in the previous part. As for all the exercises, we will ask the user to print something or to provide us the numbers of a certain array. So let's just simply extract this extract this to another method. And let's call this method. This method would be public. It could be even private, but for now, we don't really care about encapsulation and access modifiers. We have already talked about them. So we have a public. We will return an int array. Get user array, and then we will move all the code here. Okay, of course, then we don't have to do this for, sorry, we need this for, but then what we want to do here is return the array. Return my third array, and that should be fine. So in this case, we can say here simply my third array equals to get user user array, and that should actually do it. Now we have here an error. Okay, we have to make this static, of course, because otherwise it won't work. So now we can simply just use this, and we will have here a new array. And then we can just simply print the number in it. And as you will see, the behavior is exactly the same. But we have to also delete these parts here because we don't need like this one. So we can also delete this one. And now we should be good to go. So if we run this application right now, it will have exactly the same behavior. We have to specify a number, which let's say is 5. Then the first element, let's make it 158. The second element, let's make it 45. And the third element, let's make it 12. Then the next element, let's make it 78. Then another 45. And then we print the numbers here. And that's exactly what we want to do. Now, we don't want to print this anymore right now, because what we want to do here as a next exercise is go to different parts or exercises that you might receive as questions during your interviews. And the first thing, or one of the first things that you might get is, how can you reverse the contents of an array in C#? Now, for that, we will also let's make this smaller because we don't really need it anymore. Let's create a method for that. So we would have public static, and let's call it reverse array. And of course, it should also be void because we don't actually want to return anything. We just want to do something. And the first thing is we need the array, and the array we want to be provided by the user in this case, and we can have then var my array equals, and we can use get user array. So with this line, we have solved the problem of the array that we need. So now is how can you reverse the array? And of course, most of the times when you get questions or problems at interviews at this type of level, it's actually whenever you see that you have an exercise on an array, it basically, or it's virtually almost any time, means that you would have to create a for loop or a for each loop, but mostly a for, because you will see it will be it would be important that we can access the array elements by a dynamic index. So of course in this for it's exactly the same as the previous one, which is int I. And before we say what I should be equal, actually this concept of reversing an array in C# is well, actually it has two parts, I would say. The first one is that if you want to return a new array in which all the elements are reversed, then you would have, of course, to create another array. Like for instance, let's have var inversed array, and that would be equal new int array, and that would be, sorry, new int array, and the length of this array would be the length of my array, because it would have the exact same length. So what this means is actually that we can now actually go through this first array in reverse order, so we can start from the last element and add that element actually at the first place of actually the inverted array that we actually want to have. So in this case, we would have here int I equals, and here it would be my array length. And here we would have to specify the -1. Then we would have to go over and iterate until I is greater than or equal to 0. And here it's important that we have the equal to 0 because the first element of the array is always on the index 0. And then here in this case, instead of increasing after each iteration, we simply just decrement or decrease the value of I. And that's actually very, very important because right now, if we want to print everything on the console, we can say here just console write. And here we can also use string interpolation. And here what we would have to do is go through the my array. And we can say simply access the element of my array that is on the position that of the specified index, and maybe add also a comma afterwards. And of course we don't need typos here, so that should be okay right now. Let's run the application once again. In this case we provide 3. Let's have 74, 12 and 45. Of course we have to also call the method. We have this reverse array, and we don't want to have this anymore, but we just call reverse array. And reverse array will prompt us to specify the length of the array, which is once again 3. Let's have 96, let's have 78, and let's have 11. And then we have the reverse order. Now, of course, if we want to add and return a new array, we would have to make sure that we add this element to the first position of the second array and so on. But in this case, we just wanted to print actually this array in reverse order. And here the point is, when you see this type of exercises, when you have to do something in the reverse order of the certain array, it actually always means that, or almost always means that you would actually have to set the I to the length of the array -1, and then you would have to go through the iteration until I is greater than or equal to 0, because 0 is the first index, and then decrease I. So we'll have here a decrement, not an increment, which is very, very important. So this on this type of exercises, you virtually always have to decrement and not to increment. Then another common exercise that you would get a lot when we talk about, or when you have an interview on C# is, how can you print the sum of an array? So here, for instance, let's create a new method for that. So we would have public static void, let's call get array sum. And actually that's once again very easy. First step, as always, we would have to ask the user for the array. We have already a method for that, and then we can reuse it, and then the exercise itself. Now, what we need here always when you have this type of exercises, that you have to retrieve a sum or a product or whatever, actually this always means that you need another variable to hold a certain value. So, and while you iterate through the array, you actually calculate something and place that in that specific variable. So what we could do here is have var sum, and that should be equal to 0, because a sum, or with the sum, we start with 0. And here, once again, then for the same thing, we have this for loop that we virtually always have with arrays, although in this case we could also use a for each loop, but let's use for to get accustomed with the indexers here. So in this case we can have a normal for loop with an increment and not a decrement. So in this case we start from I equals 0, so the value of the first index, and then we go further until I is less than my array dot length. And then, of course, in this case, as said, we increment, just simply increment the value of I. So this means that whenever we actually go through a cycle and arrive here at this point, we can just simply add the current item to the sum that we already have. So in this case, it would be sum. So the more extensive way to write this is sum equals sum plus my array of I, which would be, of course, okay, so it's nothing wrong with that. But if you want to actually use less letters, then you can simply say that sum plus equals my array of I, and then that's exactly the same. So what we can do here, of course, we can simply write to the console or print to the console what the current sum of the array is. So I will just use this statement here, like we have this console write line, and sum of my array is, and we print the sum. Let's also add a colon here. And of course, we would also have to get array sum and write it here, get array sum, and that should be it. Let's comment out the other one so that we don't have to go through all the exercises each time that we start the console. So we just go to it. Let's, once again, we have 3 elements. Let's add 4, let's add 5, and let's add 6. And in this case, we see that the sum of the array is 15, which I suppose is correct, because I can think that .NET and C# can or is very, very accurate when it is about adding numbers. So that would be this exercise with the sum. Now, another very common exercise is that where there are a few variations of exercises that actually all have something to do with this sum. And one of them, for instance, is to get the sum of only even numbers, for instance. And we could have here another method, void get even sum. And actually what we'll do here is will simply reuse this code. But in this case, there is only one thing that we have to do. Now, the idea is that we have to find a way. So whenever we are here at this point of adding something to this sum, sorry, here, we have to do a check first. So it's exactly the same as the previous exercise. The only variation here is that we actually need to add an if. And of course, what we need to do here is we can add, or we can use the modulo or operator and say that if here my array of I modulo, where is it, 2 equals 0, then and only then we want to add this sum. And since we have only one thing here, it's not necessary that we add the brackets. If you would like to add them, you could do it, and it could be something like that. But I said, as we have only one single line after the if, we can just simply get rid of this and make everything easier to read. And we can eventually make it even easier than that. We can just simply add everything on this single line. So once again, the idea is the same when you want to calculate a certain sum. It's no matter what type of sum. You just need a variable here, and depending of the requirement of the exercise, well, what you would have to do here is you can simply just verify the requirement. In this case, we want to divide the number by 2, and if the remainder is 0, it means that it is even. So in this case, we can simply add that to the sum. If the remainder is 1, that it means that the number is odd. And in that case, of course, we will not go through this because this if will never execute, or what's inside that if will never execute. And then that's exactly the same that we would do here. Let's also add this to the console. And how was it called? Get even sum. And that would be let's have an array of 3 elements. The first is 1, the second is 2, the third is 3, and guess what? The sum should be 2 because 2 is the only even element in this array. And this actually works right now. Good. So this is actually everything that I wanted to go through right now. So once again, as a summary, we have started to look into some very specific data types. In this case, we looked into the concept of arrays, which is very, very specific and has a few very important characteristics that you have to be aware of if you go to interviews, but even in day-to-day programming, you have to be aware of these characteristics of arrays in C#. So in the next lesson, we will go over to another concept of arrays, which are multidimensional arrays, and we will play just a little bit also with multidimensional arrays. But for now, thank you very much for watching, and I hope I get you there to the next part of this lesson as soon as possible. Have a great day.